Welcome back to The Explainer. You know those massive outages that bring websites, airlines, and sometimes entire services to a grinding halt? Well, today we're pulling back the curtain to show you why these catastrophic failures are rarely just a simple accident. All right, so this is part 2 of our big 6-part series, which is all based on a fantastic analysis from Virtualization Options LLC. In this explainer, we're really digging into Chapter 2 of their report to uncover the common threads, the usual suspects, that turn a small glitch into one of those headline-grabbing meltdowns. So, when a major service you use every day just vanishes, the first thing we all ask is, what happened? We go looking for that one single reason, that smoking gun. But you know what? The truth is rarely that simple. It's usually a lot messier. Yeah, it's less of a single culprit and more like a conspiracy of causes. So let's put on our detective hats and investigate a whole rogues gallery of recurring suspects. We're going to start with the most physical, tangible ones, the stuff you can actually see and touch. First up on our suspect list are failures that are rooted in the physical world, the actual hardware that our networks are built on, and of course, the power grid that keeps it all running. Let's start with the obvious. Stuff just wears out. Solder joints get brittle, cables corrode. It happens. But get this. The source material points out that for every 10 degrees Celsius hotter a component gets, its lifespan can literally be cut in half. That's crazy. Throw in some hidden defects from the factory, and you've got a perfect storm for things to fail all at once. And then there's power. It's the ultimate dependency. It often starts with something like a storm knocking out an already creaky power grid. But here's where things really go off the rails, when the backups fail. The UPS batteries are dead, the generators won't kick on, or they just plain run out of gas. And just like that, a temporary blip becomes a massive, damaging outage. Okay, so we've looked at the stuff you can literally kick. Now let's move on to our next set of suspects. We're leaving the physical world behind and entering the world of code and configuration. Those invisible ghosts that haunt the machine. The very software that runs our world has become its Achilles heel. I mean, we're talking about systems with millions of lines of code. It's almost guaranteed there are going to be bugs hiding in there. And in today's connected world, one tiny bug can ripple across the entire internet. It creates this awful dilemma for engineers. Do you live with the bug you know, or risk releasing a patch that creates a brand new one? Okay, but check this out. This is what really gets me. For all the talk about broken hardware and buggy software, one of the biggest, most persistent culprits? Simple mistakes. A typo, a wrong setting. Over a quarter of all outages are caused by misconfigurations, and get this, a whopping 40% of incidents happen right after someone makes a change. And that leads to this really dangerous idea called configuration drift. Imagine this. Over the years, engineers make little tweaks, quick fixes, and temporary changes, but they don't always write them down. Eventually, the system in the real world looks nothing like the official blueprint. Nobody really knows how it works anymore, and making the next change feels like a game of Russian roulette. All right, so we've pointed the finger at the hardware and the software, but what if the biggest vulnerability in this whole setup is actually us? Let's talk about the human factor. Brace yourself for this number. After everything we've talked about, it turns out that human error is a factor in up to 70% of all major incidents. Just let that sink in for a second. Up to 70%. That's a huge, almost unbelievable number. It shows that, so often, we are the weakest link. And look, the key takeaway here isn't to blame people or call them incompetent. It's not about that at all. As you can see, these errors range from a simple typo, a slip, to forgetting a step, which is a lapse. The real problem is that we've built systems that are so incredibly complex, they're just beyond what any one person can perfectly manage, especially when the pressure is on. So far, all of our suspects have been accidental, right? Things that just go wrong. But our next suspect, well, this one brings malicious intent into the picture. We're talking about deliberate attacks from the outside. Yeah, we are way past your old-school computer viruses. Today's threats are full-on strategic weapons. We're talking about sophisticated ransomware, massive DDoS attacks that use bot armies to just flood a network into submission, and even zero-day exploits, where attackers use a vulnerability before the good guys even know it exists. Okay, let's recap. We've met our suspects. We've got faulty hardware, buggy code, human error, and outside attacks. But the real danger, the heart of the conspiracy, isn't any one of them alone. It's how they team up. And this is the perfect illustration of what's called the cascade effect. Think of it like dominoes. It starts small, with one little service in the back failing. Then the service that depends on it freezes. The one above that starts hammering it with retry requests, making everything worse. And that failure just cascades up the chain until, bam, the entire system that you see as a user completely collapses. You know, this quote from the source material just hits the nail on the head. Our modern services are so interconnected, so tightly coupled, that one little error can spread like wildfire, and you never know where it's going to pop up next. A single typo or one overheating switch can have a massive, unpredictable blast radius. So, what's the big takeaway here? It's that these modern failures aren't simple accidents. They're systemic. They are a conspiracy between our hardware, our software, our own human fallibility, and outside threats, all made worse by the insane complexity we've created. And that leaves us with a really tough question. As we keep building this more connected world, are these kinds of catastrophic failures just inevitable?